Suppose that you're hit by an object that has got a mass of 4 kg, and if you're hit by an object that has got a mass of half a kg, in which of the cases you're hurt more? And your answer is 4 kg. I would say no. How can you say that? How can you say that? Now suppose that this is my person who is standing over here. Okay, this is the person standing over here, and this is the mass of 4 kg, and this is the mass of half a kg, and is hit. Then in which of the cases he'll hurt more? So a common answer is 4 kg, but in that case you need to understand one thing, or you need to question one thing, that what is the speed? What is the speed or the velocity of the thing that is coming and hitting you? So if you know this, only then you'll be able to tell which of the two objects will hurt you more. Okay? Now, in the same way, we'll talk about this, but in the same way, when we learn that all the gases kept at same temperature and pressure, so kept at same T and P, have same volumes. Okay, now let's try to understand this. Now it is synonymous to this one. Over here I've got a piston, okay, and another piston over here, let's make, and it has also got the gas. So let's take our gases. In this cylinder I've got a piston, I've got a carbon dioxide gas, and in this piston I've got hydrogen gas. It's like, 4 kg or half kg. It's similarly, carbon dioxide is quite heavier, that means 22 times heavier than hydrogen. Okay, so if you're asked that which of this will hit the walls of the container with greater intensity, then the answer would be carbon dioxide. Okay, but that's wrong. In the same way as this is my person, and if it's hit by 4 kg, then and hit by half a kg, then in which of the cases he is hurt more? So as I told you, that when you ask this question, what is the speed, that means that 4 kg has been given a speed by some person who lifted it up, and then he burnt his calories by uh, undergoing some chemical reactions, and then he transferred his chemical energy into the body of mass 4 kg. So the question is that how much of the energy has been transferred into it? Okay, and from where do you get this energy? In this case we are getting the energy from the combustion of carbohydrates, and that gives you heat, and that chemical energy is converted to kinetic energy. In the same way, over here, these substances or these gases get their energy from the temperature. Okay, now suppose that the same amount of temperature, same amount of heat is being transferred to these two things, so they will do the same work. Okay, the only thing is that if you give the same amount of energy to 4 kg and half a kg, the 4 kg will move slowly and the half a kg will move faster in order to have the same impact on the person. Okay, in the same way, a gas that is bigger, so let's take our bigger gas. So in this case, this is our bigger gas molecules over here, and for this case we have got smaller gas particles over here. Okay, let's take a different color for it. Okay, smaller gas particles over here, and these are my hydrogen particles. Okay, so since this gas is bigger, it will move slowly because same kind of energy has been transferred. If this was not there, then somewhere we are defying the law of conservation of energy. This means, how can a substance on its own impart more energy to the person who is standing over here when same kind of energy is transferred to these two things? Okay, so it is just a carrier of energy. I've just put in some energy into it. I've put in some energy into this. It's just carrying my energy. That means what I what I've burnt by the combustion of my carbohydrate molecules, I transfer that energy into it. So this is just a carrier that is transferring that energy that I filled in it, and it went into this person. Okay, so it it cannot on its own give some more energy. Okay, in the same way, we have got carbon dioxide molecules over here, which is heavier, and I give it some heat through the temperature, and this also. The only difference is that this particle of hydrogen will move faster, and this particle of carbon dioxide will move slower in order to have the same impact, which is why when gases are kept at the same temperature, okay, and pressure, okay, so they have the same volume. Now suppose that this is the pressure on the top of it, so they will hit the container over here. Suppose it's hitting over here, and this particle is hitting over here, but the intensity with which they hit the container or the piston over here will be the same. So irrespective of the mass of the particle, you get the same hittings. Okay, so which is why all the gases that are kept at the same temperature and pressure have same volumes.